Oh, I agree.
So, I mean, this
And
is
I'm
your
just-
first annular eclipse. I mean, was it what you expected?
It is to hear. I mean, we've seen all of the photos from previous annular eclipses, but just as I look again, I mean, it's incredible how the moon and the sun are able to line up like this.
And again, I mean, the moon is way smaller than the sun, but right now it's really giving it a run for its money.
It is, yeah.
Why is that?
Well, so a little fun fact about our moon that's pretty incredible. It's 400 times smaller than the sun, but it's also 400 times closer to the Earth.
No
and
way,
that
400 and
400 is the
400?
magic number here, yeah. The fact that 400 and 400, that means in the sky, the moon and the sun appear to be the same size. And that is unique to us on Earth. No other planet in our solar system has that ratio that makes it so special.
So you're saying that if we viewed an eclipse on another planet, it wouldn't look like this?
It wouldn't. I mean, I'm sure it would be great to see, but it would not look as spectacular as this.
Wow, okay, I'm gonna turn behind me really fast.
Yeah, looking around. And you can just see everything. The shadows are a little bit different. It's dim. You get this hazy feeling, but the sky is still blue. That's what's strange about it.
Oh, it's so sweet. We've got parents like holding little eclipse glasses on their kids to look up. This is just, it's really amazing how just like, I don't know, a natural phenomenon can really make the world pause for a second.
It's great.
Wow.
You heard the cheering, and now it's quiet
now
again
it's
as people
quiet.
are just looking.
And so for us, this is gonna last about 4 minutes until it crosses, right?
That's right.
And why is that? Is that the same in every city or?
Yeah, so there's actually the length of the maximum eclipse can change based on several factors. I mean, each eclipse is unique. And so one thing has to do with where in the moon's orbit the moon is, because the moon's orbit isn't circular. So it will go faster and slower at different parts. And that will make the shadow travel at different speeds. Also, where the shadow is landing on Earth will have an impact, because if you're at the equator, you're going to be rotating much faster than if you were at the poles. And so for that fact, it changes the length of that maximum eclipse too. And that's true not just for annular eclipses, but for the partial eclipses, for the totality, for total solar eclipses as well. And I imagine, you know, our folks at home getting some of those partial eclipses are also having a great experience too.
Wow. I don't know what I expected, but it wasn't this. Like, this is incredible. And so, Gina, I'm sure, I mean, you're in heliophysics, sun science. I'm sure some of your teams are studying today's eclipse. Like,
oh yeah,
what?
Absolutely.
So, what kind of science can only happen right now, you know?
Right. We've heard about the sounding rockets that are experimenting.
Oh,
you
that's
know,
right.
today,
We saw one, yeah.
studying the upper atmosphere. And so we're really interested in knowing, like right now in our location, as that radiation from the sun's being blocked, how does the upper atmosphere change? And so in addition to that, I mean, we really want to understand how those sunspots, what's going on when they're covered versus when they are not covered. We can tell the difference in that radiation that's coming from the sun. And so there's so much science that we can do.
And this is just, folks, view is just so incredible. Before we fully pass through this transit, let's check in with James at our Eclipse desk. James, I know you are seeing this. What do you think?
It's truly a surreal moment. It feels like almost nighttime. It's been really breezy, chilly.
That was so
the shadows
awesome.
are all like little rings as well. It's just a beautiful sight. Kind of hard to put into words the exact feeling. I mean, we've been preparing for this for a while. We've, been tracking this all morning with our Eclipse Explorer, but actually to see it in person and to take it in, it's a really incredible moment, and this only lasted about 4 minutes. You can see on our Eclipse Explorer, this is already passing off of Kerrville, heading further southeast to parts of the Texas coast on the Gulf. And the morning is far from over here. For a lot of folks in Central America and South America, their morning is just starting off here. The partial eclipse is affecting still a large part of the region. You can see this whole area that's highlighted here in the larger ellipse here. That's all being affected still by that partial eclipse. And you can see on our track that this is going to continue moving further southeast all the way into parts of South America before the morning's over. It's been just incredible tracking this. And actually, Kerrville, we're in the path of the total solar eclipse for next year. So if I turn on the path for next year, you can see X marks the spot here in Kerrville. We're going to be coming right back here to witness this incredible cosmic event once again, getting that incredible view. Just really, again, very hard to put into words just how amazing this is. Just a stunning experience, and it's been an honor to be here with you this morning, tracking this event as it's moved across. We started the morning in Eugene, Oregon. Now it has arrived and already passed us in Kerrville. I'll continue to track it for a little bit longer here, but for now, back to you, Tahira.
Thank you, James. And folks, this is just the beginning. Today's event kickstarts NASA's Heliophysics Big Year, which is a year where we're encouraging people to do as many sun-related activities as possible in the lead up to next year's total solar eclipse. Now, Joy and Michael in Albuquerque are going to share some of the ways you can play a part. Joy, what can we look forward to?
Now that the annular eclipse is here, the fun has just begun. So today is the official launch of NASA's Heliophysics Big Year. This is a year-long celebration of solar science, and it's modeled after the Big Year concept from citizen scientists in the bird-watching community. So they're challenged to see as many birds as they can, but in the Heliophysics Big Year, we're challenging you to do as many sun science-related activities as possible. And so one way to participate is through NASA's citizen science projects. Here are a few sun-related ones you could join.
Did you know that you can participate in solar eclipse science with NASA? NASA's citizen science projects are collaborations between scientists and members of the public, no matter your citizenship. Several volunteer science projects are gearing up for the 2024 total solar eclipse that you can join. Total solar eclipses don't just look cool, they provide a rare chance to see the sun's faint outer atmosphere. Using telescopes and cameras that are safe for viewing the sun, volunteer scientists across North America will capture images of the total solar eclipse. Scientists will study these images in detail, tracking how plumes of solar material move through the sun's atmosphere. But be careful, without proper tools and techniques, you can damage your eyes and your camera. Did you know you can listen to an eclipse too? Amateur or ham radio operators will send radio messages to one another during the eclipse to see how changes in the upper atmosphere distort radio signals. As the moon blocks one portion of the sun, it can make other portions easier to see. Working with local scientists at an observatory in Southern California, participants will observe magnetic hotspots on the sun as the moon passes over them, revealing details they normally can't detect. Want to learn more? Follow Do NASA Science on X and Facebook to see how you can get involved in NASA citizen science.
So as you can see in the telescope view, the moon is now moving away from the sun, which is really, really amazing that we're still seeing this partial eclipse.
Absolutely, and I think I can see a sunspot in there too, and I think on one of the earlier shots, I could see a prominence. So we're seeing NASA's sun science happening in real time.
So we're getting some amazing questions online. Shall we ask some more?
Yeah, let's get into it.
Answer some more. Okay, so we have a question from Peter Chang on X, and they ask, can filtered telescopes see flares on the sun during totality?
Oh, that's a really good question. The answer is yes. It depends on what filter, though. So if you use just a white light filter, then you have to have an exceptionally large flare in order to be able to see it. If you use a filter like an H-alpha filter that specifically selects one color of red light, then you're going to be able to see flares a little bit more frequently, even even during totality as the corona adjusts to that flare as it erupts.
Okay, so we have time for one more question. Yuri on X asks, if a solar system had more than one star, would they have more solar eclipses? Would they all look like the same eclipses that we have here on Earth?
Ooh, that is getting a little sci-fi, but that's okay. So if we had more than one sun, you'd have to have a moon to block both suns, or maybe two moons to block both suns. So you'd have to have a very complex geometry to get everything lined up perfectly so you could get solar eclipses with two suns and two moons, and oh, it would get very complicated.
Thank you so much, Michael.
You're welcome.
Okay, so now we're joined with NASA's heliophysics lead, Denise Hill, who's going to tell us more about how you can participate in the heliophysics big year. Hi, Denise, how are you today?
Great. Did you see that? That was my first annular eclipse, and we got a prominence. I am so stoked. That was the dopest thing ever. Okay, okay. Heliophysics big year. So, as you've heard before, the sun touches everything. And the Heliophysics Big Year is a celebration, a global celebration of sun and sun science and what we have going on. But it's also, I think I heard you say it, Michael, it's about the community and being communal and just the unity of hearing everybody cheer. The sun touches us all in so many different ways. And so the Heliophysics Big Year is going to help us kind of discover all the ways the sun touches us scientifically, but in other ways as well.
And why is it a big year for the sun?
So you saw what just happened, right? Oh, well, that's nothing. Coming up in April 8th, we have the total solar eclipse, and then Parker Solar Probe's closest approach, which will end out the Heliophysics Big Year, but it's the mission that has literally touched the sun, and it's going to be making its closest approach. And then from there, every single month during the Heliophysics Big Year, and it's a big year because it's more than 12 months, but during that time, we have themes for on different ways people can explore the sun and how it touches them. So we have themes like fashion. We're going to be delving into physical and mental and emotional health. The sun touches us in so many ways besides. And then we have missions. In just a couple weeks, we have our AWE mission that is launching, and it's going to be the first space weather station on ISS. And we are so excited. You have no idea.
Wow, there's so many new NASA events and opportunities coming up. Is there any other like science events that maybe people could get involved with themselves?
Yeah, for sure. So we've talked about citizen science a bunch, and that is one of the ways for sure for people to get involved and to do NASA science with real scientists. And then there's also, like, you are a scientist. Every single one of us is a scientist. And we're going to share ways that you can explore the sun, do your own little scientific investigations yourself. And so, yeah, the science is going to be front and center. There's also going to be some other things as well.
That's great. So what are you most excited about in this upcoming big year?
For me, it's the unity, right? Like the sun touches, it doesn't matter what race you are, what ethnicity, what culture, religion, whether you live in a rural community, urban community, it doesn't matter. The sun touches us all. And we like to call it our extraordinarily ordinary sun, because our sun is supposed to just be ordinary. But it is responsible and touches every living thing on Earth. And no other star that we know of has that level of responsibility. So that gives me hope that you can be ordinary and have an extraordinary impact.
That's amazing.
Well, I think our sun's pretty extraordinary by itself, so I don't know.
Thank you so much for joining us, Denise.
Thanks for having me.
So if you want to learn more about the Heliophysics Big Year, you can visit go.nasa.gov/heliobigyear. Michael, are you excited for the Heliophysics Big Year?
I am so excited because I get to be a rock star for an entire year, and then I go back to being a normal scientist again. No, it's going to be fantastic for science, for outreach, for everything. I am so excited for this.
Well, the Heliophysics Big Year has so many opportunities for folks around the world to get involved with NASA science, especially during the 2024 total solar eclipse. And one group of citizen scientists will be using their sensors to make observations. They'll gather sound recordings and help with data analysis to understand how wildlife will be impacted by solar eclipses. And you can help them too, no matter your citizenship. So now let's learn more.
During a total solar eclipse, it is almost like day becomes night very quickly.
So knowing that there's going to be a change in that light and life-giving energy means that we can predict when animals are going to have a rapid shift in their behavior,
which results in changes in the acoustic environment or the soundscape.
So the Eclipse Soundscapes project is a project to determine how eclipses affect life here on Earth.
And there's a lot more to observation than just what you see. It's also important to think about what you hear.
We're measuring how the rapid onset of darkness during an eclipse affects wildlife by measuring the changes in sounds that they make.
The general public is best suited for this type of project because the general public is everywhere.
And that's really the power of the participatory science component of this project. It enables recordings and observations of soundscapes across the diversity of ecosystems covered by the path of totality. We might think of some ecosystems having a greater influence of human activities on the soundscape, whereas in other ecosystems, say a remote part of a national park, we might have a lower influence of human activities and greater influence from the sounds of life and earth.
The only way to properly preserve a species is to understand it. The only way to understand it is through scientific study on their behavior, their patterns, and their habitat requirements. One of the things we'll be doing during the total solar eclipse is setting up these recording stations. So these are our acoustic monitoring stations. And what we're doing is listening for calls of the different bat species with the hopes of maybe picking up some of those endangered species like the northern long-eared bat. We're hoping the results of this study will inform us about the health of our bat populations on Hot Springs National Park and help improve future conservation efforts.
The Eclipse Soundscapes project is an inclusive and accessible project that is inviting the general public to get involved in NASA science alongside scientists and subject matter experts.
Wherever you take your observations, you might be giving us information that has never been recorded before. And that is really useful and interesting to a scientist.
Wow, that sounds like an exciting project that anyone can get involved with. So if you want to learn more about Eclipse Soundscapes or any of other NASA's other citizen science opportunities, go to go.nasa.gov/HeliaBigYear. Well, thank you to everyone joining us online and here in Albuquerque, New Mexico. It's been an unforgettable day, hasn't it, Michael?
Oh, it certainly has. I will never forget this day. It has been just a day full of activity and memories that will last a lifetime.
So although the annular eclipse is over in Albuquerque, we still have one more day left at the Balloon Fiesta and 1 year to participate in as many sun science-related activities as possible in the Heliophysics Big Year. So now let's head back to Kerrville, Texas, where Tahira and Gina will chat about the upcoming total solar eclipse. Thank you so much for joining us, everyone.
Thanks, everyone.
And thank you, Joy and Michael. I mean, it sounds like we have so much to look forward to over this next year. And folks, even though peak annularity just passed in Kerrville, Texas, we are still getting an incredible view on this live telescope feed. You can see the moon is now passing over the sun and honestly on its way to make another city's day. Now, it is a good point to remind folks that X marks the spot here in Kerrville, Texas, where the 2024 total solar eclipse will pass in just 6 months. This very lucky city is in the path of totality and will be one of the places to witness the moon completely blocking out the face of the sun and darkening the sky as if it were dawn or dusk. Now, Gina and I are here with NASA Chief Scientist, Dr. Kate Calvin, to learn more about what we can expect for next year. Kate, thank you so much for being here with us.
Thanks for having me.
Have you. And so, Kate, can you start off and just give us an idea of what science we can expect only for a total solar eclipse?
So one of the things that scientists are really interested in studying is called the corona. It's a part of the sun's atmosphere. It's the source of heat and particles that come towards Earth. But normally it's too bright, and so you can't really observe it directly. Scientists use instruments called chronographs to block some of that light, but it's still hard to see parts of the corona.
It's not the same as a total eclipse?
Yeah, the total eclipse gives the best environment for studying the corona.
Right, but we were so lucky to just see that prominence coming off of the sun.
And what is the prominence?
And so that's actually some of that solar particles, some of the particles coming off of the sun, the ejecta, and we can kind of see it hanging there, which either turns into an eruption, some of that activity that we can observe, or it can kind of just quiet down as well.
Yeah. So, Kate, can you tell us, how can the public get involved with the total solar eclipse?
Oh, that's a
coming
good
up?
question.
Yeah, so we have a number of citizen science projects. These are projects where people anywhere around the world can help contribute to our science. You don't have to be in the path of totality to contribute. We have projects for everyone. And they're different projects. Some of them you need cameras or telescopes or equipment. Others you can use just with your cell phone. And so we have one project that's called On the Globe Observer app. It's help understand the effect of eclipses on Earth's weather, and you can do that just with your phone.
Do you need a science background, or?
Anyone can contribute. We walk you through what you need to do, and sometimes it's as simple as taking a picture or recording a sound. And so you can all contribute to our science.
So anybody can get involved?
Anyone can get involved.
Perfect. And then can you tell us a little more how the eclipse science that we're doing will help to inform kind of the broader science at NASA?
Yeah, and so like I said, we're trying to study the corona, the source of heat and particles towards Earth. They affect Earth. They can disrupt electronics. They can lead to northern lights. So we're really interested in that in Earth and understanding the effects on Earth. But there's also the sun affects other planets and bodies in the solar system, like the moon and Mars. And so when we think about exploring the solar system, we want to understand the sun and its role in it.
Wow, that's incredible. I mean, we have so much to look forward to next year. I want to know real quick, what's your peak excitement for next year's total solar eclipse? We'll start with you, and then Kate would love to hear your thoughts.
Sure. So I'm really excited to compare what we saw today, that annular eclipse. How does it compare to that total solar eclipse? I got to see a total in 2017, but every eclipse is unique, and so
such a scientist.
I know.
Want to do
that
a
is
little
my experiment. How many data points can I get? But not just that. We're hearing everything about the heliophysics big year, and so it kicks off today, and that total solar eclipse in April will be the next event. So how many events can I participate in for the heliophysics big year?
Amazing. What about you, Kate?
I'm interested in sort of the things beyond just what you see, but what you feel, so that it's going to get cooler, and we might hear some animals.
Today, we felt that.
Yeah, and I really want the full body experience of the eclipse.
That is incredible. And I mean, today has been a spectacular day. So folks, let's check in one last time with James at our eclipse desk to see how he's doing. James, what's it like?
Yeah, Tahira, I'm still in awe of the moment that we just had here a couple minutes ago here in Kerrville, Texas. Just a stunning view of that ring of fire here. And as you can see on our Eclipse Explorer, the annularity has now shifted off into the Gulf of Mexico. So if you're in a boat out there, you'll have a phenomenal view. But we're going to be here once again next year, April 8th, 2024 in Kerrville, Texas. I've got the path of the 2024 total solar eclipse up here on the screen. You can see it's tracking right through us in Kerrville and then affecting an entirely new area here that is going to be stretching all the way up to parts of New England, all the way up to Maine, even parts of Canada. So a really large area there as well. So definitely save those pinhole projectors and certainly keep a hold of those eclipse glasses. You're going to need them for next year. We're going to be right back to cover all of that incredible stuff next year with you. It's been amazing tracking this today. And again, this is still moving onwards to Central America and South America. So if you're tuning in from there, you have a great view incoming. And in many parts of the country, there's still that partial eclipse. A truly awe-inspiring morning and a wonderful day for all. So thank you so much. Back to you, Tahira.
And thank you so much, James, for bringing us into the action during today's show. Gina, so wow. I mean, this was both of our first experiences. So final thoughts.
I mean, what a day. At this point, I'm ready to look at those calculations for the eclipses and check out not only April, but what else can I see in the future, because these are spectacular to
A little
see.
eclipse chaser
Exactly.
now.
I'll chase them around the world.
No, and it has been so fantastic having you on today's show to really just help break down what we are experiencing today. And so again, thank you so much for everything.
Thank you for having me.
And folks, the action isn't over yet. You can continue to watch views of today's annular eclipse as it moves across the path by visiting go.nasa.gov/eclipse 2023 live. That live stream will continue running until 4:30 p.m. Eastern as this eclipse continues its way through Central and South America. Now, unlike today's Ring of Fire effect, we are going to witness the moon completely block out the face of the sun during next year's total solar eclipse. The sky is going to darken as if it were dawn or dusk. You can learn more about eclipses and what's in store for April 8th, 2024 by visiting go.nasa.gov/eclipses. The total solar eclipse is sure to be a rare event and one you will not want to miss. So stay up to date with sun-related events and how we are studying our star by following NASA's Sun on social media. Folks, thank you to everyone who has tuned in to today's coverage of the 2023 annular solar eclipse. We hope to see you back here next April as we ring in the last total solar eclipse that will pass through the mainland U.S. for 2 decades. Now, here's how you can celebrate the countdown to April 8th by joining our heliophysics big year.
We are one of 100 billion stars in a vast galaxy, but for all of human culture on Earth, one sun that nourishes us all.
That is what stirs humankind. That's what unites us.
Experience the wonder, the beauty, and the power of our star.
One sun across space, time, and culture.
Let us continue the quest to unfold this universe. And let us continue to find unity in our discovery.
Probably 2 million asteroids in our solar system.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal.
One of the ingredients that went into making our Earth, and one that we cannot see any other way. And it would be the first metal object that humankind has ever visited.
Studying the evolution of a planetary body is a detective story.
I think the only thing we know is that it's not going to look like what we think it's going to look like, and it's going to be really interesting, whatever we find.
Space is always more amazing than we can imagine with our minds.
You're looking live at NASA's Kennedy Space Center's Launch Pad 39A. Fueling of that SpaceX Falcon Heavy rocket should have began a couple of seconds ago for the Psyche mission to a mysterious metal asteroid. Welcome, and thank you for joining us live from the Space Coast of Florida for this first of its kind mission. I'm NASA's Megan Cruz, and this is Jim Bell, a professor at Arizona State University. Great to have you here.
Spectacular, great, good morning. Launch day, launch day, launch day, super exciting.
You have a lot of excitement, and I'm glad to see it.
Yes.
As he said, launch day, so liftoff is targeted for exactly 10:19 and 43 seconds Eastern Time. The name Psyche refers to the spacecraft we're launching today, but also the asteroid we're sending the spacecraft to. And we actually have a model of the asteroid right here, a very baby model.
Tiny model, right?
A lot smaller than the real thing.
Yes, the real asteroid is about as wide as the state of Massachusetts, so it is a very, very large asteroid. It was discovered in 1852 by an Italian astronomer, and he named it Psyche after the Greek goddess of the soul.
Beautiful name.
Yeah, so because of that, we named our spacecraft Psyche. And because of that, we named our mission Psyche. So the focus is on Psyche, Psyche, Psyche.
Yep.
We're really focusing on really getting to know this little world.
All makes sense to me, easy to remember.
Yes. Exactly.
So as you place that asteroid down, tell me where Psyche is in relation to us and our solar system.
Right, well, you remember elementary school, right? Mercury, Venus, Earth, Mars, Jupiter, right? And between Mars and Jupiter is the main asteroid belt. And this asteroid orbits in the main asteroid belt between Mars and Jupiter about 3 times as far from the sun as the Earth.
And really quick, a very unique asteroid, obviously, metal rich.
It's metal rich, and it's the largest one of its kind in the entire solar system.
And that's why we're going to it.
Yes.
And there is a lot to learn about this mission. That's why Jim and I aren't the only ones you'll hear from today. We have Jasmine Hopkins here at Kennedy Space Center at a nearby viewing location, Raquel Villanueva at NASA's Jet Propulsion Laboratory in California, and Daryl Nail and Mick Woltman, who will walk us through the operational milestones today. All right, so guys, SpaceX has been fueling its Falcon Heavy rocket for about a couple of minutes now. And the other watch item is, of course, the weather today, but we are looking a lot better than yesterday.
Yes, we certainly are, Megan and Jim, and good morning to you both who are looking lovely in your purple and orange mission colors. Mick and I here, we're in our gray, which was the weather yesterday, but you know, great news in terms of the weather for today's launch. It improved to 85% go. We just heard a weather brief as she gave that brief to the launch director, Mike Taylor of SpaceX, and you can see it on the graphic there. 85% go. Winds are light and variable. 5 to 10 miles per hour out of the west. Temperature 82 degrees, and of course it's humid. Our only concern, though, Mick, a potential cumulus cloud in the area. We don't have any rain, as you can see on the radar. That's the best news that we got today.
Yeah, absolutely. Like Jim, I'm excited this morning. I mean, we started early this morning, Daryl, you and I listening to the nets, and the weather has only improved over the last several hours down to this 85% go, and I'm excited for that as we move into launch liftoff this morning. The range team will continue looking at the weather, and along with the engineering team on the launch vehicle, but things are looking really good this morning from a weather standpoint for this mission. I'm very excited.
The other major factor for consideration before launch is the range. As you look at a beautiful shot orbiting around the launch pad there at Launch Complex 39A, the Falcon Heavy, the 3 boosters at the bottom, and the spacecraft Psyche encapsulated at the top. That
en la Luna o en otra, en alguna de las lunas de Júpiter, de cómo les gustaría que fuera un planeta.
NY, PY, and Center Core LOX load has started.
That is the call out for LOX load. So now we were flowing RP1 propellants into the Falcon Heavy boosters,
electronics,
3 boosters at the bottom. Now we are flowing LOX, which is more of a delicate operation.
Decades.
Yeah, absolutely.
Now, here's how you can celebrate the countdown to April 8th by joining our heliophysics big year.
We are putting the cryogenic densified LOX in board.
We are one of